Okay everyone, so what you're seeing here is the exact same dot plot that we have in the lab, except I've made it kind of in a mobile form where we can take each of the dots and move them around, because that's what we're going to do here by the end of this video. Again, looking at the dot plot, making sure we understand it, it's the same as the one in the lab, meaning each one of these little caps represents the results of one of the videos that you all watched. For example, this one right here, or any of these actually. There were 4 videos that you could have watched in which 5 out of 20 of the R2s ended up on their feet. There were 3 where 4 of the 20 R2s ended up on their feet. There was that one really cool one where 11 out of the 20 R2s landed up on their feet. And there was that one down here where there was only 1 out of 20 R2s that ended up on their feet. So this is the entire gamut of what happened over the 18 different videos that you could have watched. Now what I'm going to do is, I want to kind of look at well, it's interesting. It's called the shape of this data. Do you see how, it's a little hard to see with only 18 data points, more on that later. But do you see how the data kind of rises up and then falls off? Yes, there are gaps. We're missing some gaps at 6, 8, 9, and 10 are absent. There is this weird little 11. Totally understandable. But there definitely is kind of a shape in that it seems to rise up and then fall down, even with missing parts. I want to kind of drive the point home as to why that's happening with this next bit of the video. And this was definitely the most interesting of the 18 videos. 11 out of 20 standing R2s. This down here is interesting in its own way. I mean, if for no other reason, this only happened once, and that only happened once. So they happened at the exact same rate, if you will. But they're also both what statisticians sometimes call outliers, in that they are the weird ones, the smallest and the biggest. So what statisticians sometimes do is they say, well, this one only happened 1 out of 20 times, and this one happened 11 out of 20 times. Altogether, that means they happened 12 out of 40 times. 12 out of 40. Now think about that. 12 out of 40, if you were to take those results and spread them equally across these 2 data points, this one would not be 1 out of 20 anymore, and this one would not be 11 out of 20 anymore. They would both be 6 out of 20. Now I want you to think about why. 1 plus 11 is 12. That means we got 12 standing R2s. 20 and 20 together is 40 trials. 12 standing R2s over 20 trials. If you split it evenly, and that's the important thing, if you split it evenly, that means each of those had 6 standing R2s per trial. It knocks the 11 down and it brings the 1 up, and it brings them down and up in the exact same way. We can do something similar with the remaining data. I'm going to skip the 2s for just a second to make the math nice. I'm going to focus on these 3s and these 7s. Now the 3s and the 7s, if you think about the 3s and the 7s, this 3 out of 20 and this 7 out of 20 together are 10 out of 40, which means they would be 5 out of 20, using the same logic as what we did before with 11 and 1. It would also be the same with these 2. And it would also be the same with these 2. So what you're seeing here is, you're seeing that I am stacking the data by sharing, if you will, the data. Okay, let me take a quick look to make sure we're still seeing this okay. Yep, the data points are still on the screen. We're going to run out of space here pretty soon, so I'm going to have to tilt the camera back at the end. But we can do the exact same thing with the 4s and the 6s, can't we? Because if you look at the 4s and the 6s, the 4s and the 6s can be combined to be 10 out of 40, which is, again, 5 out of 20. Now, if we take a step back, thank you, Mr. Stan. If you take a step back and look at what we've just done, we have shared all the data except for our little 2s out of 20s. These are the oddballs, right? But ignoring those for a second, it looks like the data smooths or averages to 5 out of 20. Now, how do you deal with the two little ones here? Well, what you do, you could share the 2 in with some of the 5s, or you could just say, it looks like the data averages about 5 out of 20 standing R2s, but this makes it a little bit less. All of that started from our original dot plot. But when you begin to share the data, like we just did, you end up with an average number of standing R2s per 20 of just a little bit less than 5 out of 20. This spike is 5 out of 20. Those 2 little 2s bring the average down a little bit, but it's good enough for government work at this point to understand it looks like standing R2s are averaging about 5 out of 20. More on that soon.